Have you ever wondered what happens when your body's absolute greatest defenders suddenly turn into its absolute worst enemies? Well, welcome to this explainer. Today, we're going to decode the incredibly complex, completely fascinating, and honestly sometimes terrifying world of the human immune system. And to do this, we're going to look at it strictly through the lens of a military metaphor. Because as our source material lays out, the biological warfare happening inside of you right this very second, it is every bit as strategic and sometimes just as chaotic as a real-world battlefield.
To make sense of all this, we're going to break our story down into 5 quick chapters. First, we'll meet the body's army. Then we'll look at hypersensitivity, transplants, the dark betrayal of autoimmunity, and finally, immunodeficiency. Let's jump right in. Chapter 1. The body's army. It's time to actually meet the soldiers fighting on your behalf. So our source defines immunity pretty simply. Think of it as your own personal national defense force. Whenever a foreign invader tries to cross your borders, and by invaders we're talking about biological terrorists like bacteria, viruses, fungi, or parasites, your internal army is instantly activated. And here's the kicker. An infection only happens if those invading terrorists actually manage to beat your soldiers. If your soldiers win the fight, you stay perfectly healthy. Now, within this army, you've basically got 2 elite types of soldiers, and they're actually named after the specific training camps where they mature. You've got B lymphocytes, which are trained in the bone marrow, and T lymphocytes, trained in the thymus, and they have totally different ways of doing battle. B lymphocytes run what's called humoral immunity. They literally convert themselves into plasma cells to fire off these highly targeted, long-range weapons we call antibodies. T lymphocytes, on the other hand, they manage cell-mediated immunity. They use chemical communication signals, cytokines, to trigger really intense, localized inflammation to just obliterate the invaders close up. All right, moving to our second chapter. Let's see what kind of chaos unfolds when these elite soldiers get just a little too enthusiastic. Picture this. You've got a soldier who successfully takes out a terrorist, right? But they use so much firepower doing it that they accidentally wipe out a whole city block of innocent civilians in the process. That is hypersensitivity. It's this exaggerated, wildly hyper-excited state of what is otherwise a normal immune system. These mad soldiers do destroy the foreign threat, but the collateral damage they inflict on your own body, it's absolutely catastrophic. A great example of this is the pathogenesis of a type 1 hypersensitivity reaction, which is really just the medical term for an everyday allergy. It happens in 2 phases. Notice how the very first time you're exposed to an allergen, let's say dust, you don't actually have any symptoms. But behind the scenes, your B cells are quietly forming IgE antibodies that permanently lock onto the surface of your mast cells, basically arming them. Then, the second time that dust enters your system, it binds directly to those primed antibodies, calcium floods the cell, and the mast cell literally bursts wide open, releasing granules that trigger all those miserable allergy symptoms. And the real danger here is how those bursting mast cells release histamine, because histamine can trigger anything from a localized annoyance, like a skin rash or asthma, known as atopy, all the way to a massive, full-body emergency called anaphylaxis, which literally requires adrenaline to save your life. Now, if you're trying to remember some classic exam-level examples of these allergies, the source notes highlight a fantastic mnemonic, PCTS. That stands for Prosnitz-Kuznur, Cassoni, Theobald-Smith, and Schultz-Dale phenomenon. But listen, it's not just basic allergies. There are actually 5 distinct types of hypersensitivity, and it all depends on exactly how our overexcited soldiers are causing the destruction. Type 1 is the allergy we just talked about. Type 2 is cytotoxic. This is where antibodies tag your own cells for immediate phagocytosis, which basically means they get eaten alive by other immune cells. Type 3 involves these clumpy immune complexes forming and just depositing all over your tissues, sparking massive inflammation. Type 4 is delayed, driven entirely by T cells slowly building up fibrous granulomas. And type 5? It's a really bizarre variation of type 2, where antibodies don't actually destroy the cell, but instead force it to overwork itself on a continuous, exhausting loop. Trying to keep all these complex reactions straight can be a headache, but medical students use some brilliant shorthand to remember them. Take those weird type 5 stimulatory reactions. Just remember MG, which covers myasthenia gravis and Graves' disease. And for type 3, the immune complex reactions, just think of the word SHARP. Serum sickness, Hainisch-Schönlein purpura, Arthus reaction, reactive arthritis, and polyarteritis nodosa. These little acronyms are honestly the perfect roadmap for tracking how all that collateral damage manifests. Okay, Chapter 3. Let's look at a modern medical miracle and the incredibly tragic scenario where our internal army mistakes life-saving medical aid for an invading force. Let's talk about transplants.
Think about this for a second. If you need a new kidney, your immune system is immediately going to be on high alert. So purely from the perspective of your internal soldiers, who do you think is the absolute best, safest organ donor in the entire world? Well, the answer, of course, is you. Using an autograft, which is just moving tissue from one part of your own body to another, has a 0% rejection rate. Next best is an isograft, meaning it comes from an identical twin. But let's be real. In the actual medical world, most surgeries rely on allografts, getting an organ from another human being. And because the genetics aren't a perfect identical match, your soldiers will inevitably recognize that new organ as foreign, and they're going to launch an attack. The absolute worst case scenario, by the way, is a xenograft, taking an organ from an animal, which faces basically a 100% rejection rate. And when that defensive attack happens, the timeline is just brutal. Hyperacute rejection can happen in mere minutes, literally while the patient is still on the operating table. This happens if the recipient already has preformed antibodies against the donor, causing the new organ to visibly die and fail before the surgeon even finishes stitching them up. Then there's acute rejection, which takes weeks or months as the donor's foreign cells directly rile up the host's T cells. And finally, chronic rejection, which is this slow, agonizing burn over years that gradually degrades the life-saving graft. Which brings us to Chapter 4, probably the darkest chapter in our whole explainer. This is what happens when your soldiers actively betray their homeland, even when there are absolutely no foreign terrorists around. Autoimmunity is essentially a catastrophic failure of a core biological protocol called immunological tolerance. Tolerance is the military training program that officially teaches your soldiers to ignore your own body's tissues. So, when tolerance breaks down, you get self-reactive immune cells. They aren't fighting invaders anymore, they are actively hunting down and destroying your own country's civilians. Now, your body actually has some pretty amazing built-in safeguards to prevent this mutiny, which means autoimmunity only happens when multiple backup systems fail completely. Step 1 is central tolerance. Inside the bone marrow and thymus training camps, any soldier that shows even a hint of self-reactive tendencies is instantly eliminated before they ever see the bloodstream. But sometimes a bad soldier slips through the cracks. That is exactly why we have Step 2, peripheral tolerance. This is a complex network of backup systems, constantly patrolling the blood to catch and neutralize those escapees. Autoimmune disease is born when that peripheral backup system fails, and it can happen a few different ways. It could be the breakdown of energy, where cells just forget how to be unresponsive to your own tissue, or failure of apoptosis, where rogue cells just refuse to self-destruct when ordered to. Sometimes it's caused by the release of hidden, sequestered antigens, like proteins deep inside the lens of your eye that your immune system has literally never encountered before, so the moment it sees them, it attacks them as foreign. But maybe the most fascinating is molecular mimicry. This is when an invading terrorist happens to be wearing the exact same uniform as your own healthy cells. Your immune system builds specific weapons to kill the invader, but accidentally slaughters your own tissues because, to the soldiers, they look completely identical. Finally, we reach Chapter 5, our last scenario. What on earth happens when the military draft just fails entirely, leaving us with absolutely no soldiers to fight off the terrorists? This is called immunodeficiency, and it generally comes in 3 deeply tragic forms. First, in humoral deficiency, like Bruton's disease. A missing enzyme called BTK means your B cells never actually mature. The result? Your body produces 0 antibodies. Then you have cell-mediated deficiency, like DiGeorge syndrome, where one tiny deletion on chromosome 22 means the thymus never even forms, leaving the patient with no T cells whatsoever. And the absolute most devastating scenario is severe combined immunodeficiency, or SCID. In this case, an enzyme mutation causes toxic waste to build up inside the cells, actively killing off both B and T cells, leaving the patient completely 100% defenseless against the outside world. So, from overexcited soldiers causing massive collateral damage, to straight-up traitors betraying the homeland, to a total failure to draft any defenders at all, honestly, it's a miracle we survive a single day. The biological warfare happening inside your body every single second is a wildly high-stakes game of life and death. So, considering everything that can fundamentally go wrong, have you thanked your internal army today for keeping the perfect balance? Think about that, and we'll see you in the next explainer.